Set construction, day one. We've sort of got walls laid out. I construct everything with 2x4s, kind of. I know a lot of people think of set building as like, oh, light duty, you know, conserve material, go smaller, etc., etc. It's just a big pain in the ass. At the end of the day, if you can build something heavy duty enough out of lightweight materials, and some of the things that you end up having to do are connect it rigidly to the floor and brace it all over the place, where you can't like run out at an angle and grab the floor and pin it down. In a bunch of places you paint those out black or hide them with flats and stuff, and leave something built in. This is always a musical production that I work on annually. This is like my 7th year, I want to say. And oftentimes with a musical, well, it depends. Sort of two different major ways to tackle a show. Build a set in and slightly modify it throughout the show, or make major pieces that roll around and change and come in and go out. That's what I like to do. It was what we did here when I was a student. You know, it's what the set builders and designer and people did then, and it presents a great challenge. So that's how we're going to tackle it. That being said, it's harder and harder to build things that are lightweight or out of lightweight material if you can't attach it to the floor and brace it that way. If it has to stand alone, roll around, and support weight, I'm going to have a hard time again here with just one hand. But you know, our set pieces for this show, ooh, right off the bat, fuck you. Our set pieces for this show are 2 mirror image staircases with landings. So there'll be another one just like this that goes up, landing, and up again that way, and it runs out there. And 2 separate pieces that could be rearranged like this, turn independently, yada yada. You'll see this come together. But essentially, if you need stairs, you need regular rise and run sizes, conventional. Those are the stairs that people are used to using, and they all need to be the same, and otherwise you'll have people tripping and falling, or they won't look right to scale. Stairs are very typical, standard. So again, playing games with this paper. God almighty, hang on a second. Okay. So we'll use typical 2x4, 2x8, 2x10, and 2x12 construction for this. And I've broken out the walls and noted the quantities here. Why do I do it that way? I'm going to use 2x4s. And another fun thing, you can tell somebody's a noob. By the way, this will be how you noobs hide yourselves if you're watching this video. You can tell somebody's a noob when they're at the hardware store, or if you're discussing dimensional lumber, framing lumber, like 2x4s, 6s, 8s, 10s, 12s, and everybody's bitching and moaning about, oh, you know, oh, they're warped, you know, they're twisted, or they're waney. They don't know all the different ways in which wood can be sort of questionable. There are nice sticks, and there are barked up waney boards, which are nearer the outside of the tree like that, and we've got all different sorts of ways that they could be deformed, and everybody always feels like they should all be straight sticks, and if they're not, you know, they're really low quality, whatever. Yeah, they are. This is just spruce. These are maybe $2 each, roughly. If you want to spend $3 in some, you can get Doug fir, which is going to be a nicer quality dimensional lumber. It's a nicer material. Usually Doug fir, the ends are dipped in wax, so they're not taking on moisture at the end grain. They're packed tightly just like spruce is, or white lumber like this, but the grain is also a bit tighter. The species of tree is a bit less prone to warping. But again, if you're going to spend a third more on a lumber order like we've got here and like the rest downstairs, you're going to price yourself right out of building sets. So to start with, we went with spruce or white lumber, and you end up with a little bit of curvy, you know, some curvy pieces. You can see this one has got a major problem here. And that's the way that you want to look at lumber. I see people, again, I laugh at them at the store, looking at the 2x4s, looking down the 2x4 edgeways like that. Ooh, it runs out one way or another. That's no problem. They're springy in that dimension. You can straighten that out, no issue. It's in this way, like a road. If you look down a piece of lumber, I know somebody knows what they're looking at. If you're looking down a piece of lumber like it's a road and it migrates to the right or the left, you're not going to straighten that out. You're not going to put this on its edge and go out there and push it down and straighten that lumber out. It's never going to behave. So unfortunately, this nice long 12-foot stick is going to become short pieces. I will limit how many times I make 8-footers that are nice and straight into short pieces, and I'll make a bunch of short pieces out of this long guy, because as I make a short piece, each one of those gets a fresh end, and basically you lose this arch and we end up with usable pieces here. So that's some strategy. Some other strategy, I used CAD to design my wall systems here. I figured out what my plate lengths and stuff are. All my measurements are from a flat end to a point, point to a point, point to a flat. I can always I can hang my tape on a point. I can't hang it on the short side because that's an open angle like this. You can't hang a tape on that corner. I can hang a tape on this corner. So when I dimension my drawing, I put all my dimensions to my pointed ends. And you also want to notice when you're talking about components like this, you have either trapezoids, which is what this is, or you have rhombuses, which is what's up here. This piece here, from that end to that end, is a rhombus. What does that mean? Real quick, if you remember geometry class, simply speaking, a trapezoid has 2 points on the same side, and a rhombus has a long on this side and a long point on that side. So trapezoids and rhombuses. If I'm making a rhombus, I'll give myself a dimension from point to point, because I'll put my tape on that long corner, I'll pull it down, I'll make a line on top, I'll wrap the line around, I'll turn the stick over, and I'll cut that point back there, and I'll make myself a rhombus. And on a trapezoid, I'll work with the long side facing up, and I'll cut in like that, and I'll make my component that way. So you want to be aware whether you're making rhombuses or trapezoids. And finally, since I used CAD, and I'm certain of every location and angle and length, now I can force this to behave. So I'm getting these two components. These are separate triangles here laid out, but you can see I've got the bottoms landing on a 16-inch layout all the way along, and I have an opening there. What's that about? I've got these landing where they belong, and I don't know if you can see it, but they're, rather than being plumb, they're listing. What's that about? Everybody who's fighting with cheap or frustratingly curved lumber, there's a lot of strategy here. Why is that happening? If I've made all these pieces accurate to the drawing, which is what I'm doing here, then I can be sure that if the order in which I assemble it, I will slowly force this thing into as perfect as I can possibly force it to. So I've put 1, 2, 3 corners together, and I've made sure that they work out, smoothly all the way up and down, all the way around. Then I have a framework that I can kind of move around a little bit. I'll attach the flat end on that 16-inch layout all the way down and leave these ends float, and then I'll take a hammer and I'll shove them over, bowing that piece out until they're at 90 degrees here, which I'll check with my square, and the last thing I'll do is screw them in at the top. And why is it that they're listing? Because this isn't a straight piece of lumber. This has a very, I'm going to exaggerate it, but it curves like that. So I'll shove this one over and it'll straighten out. I'll shove him and straighten out a little more. I'll shove him and he'll be almost perfectly straight. I'll throw the last guy in, and when I'm done, I'll have probably as nice of a component as you could make with this lumber. From start to finish, strategizing decent straight pieces, wherever I could find them, and cutting into little, cutting more curvy and deformed pieces into small blocks that I can lose a lot of that with. If I need long, straight sections, I get my best pieces to make those sections, and all the way down to the end, I put them together in known points, known, and attach those all to known locations here. And the last thing is, these are supposed to be at 90 degrees, so I'll push them over, pin them, and I'll end up with really nice components. And I'll do the same thing over here. And why is it, again, that we don't, you won't see a drawing like this on a construction site for a home or anything like that. We don't call out specific locations of studs and dimensions and everything like that, because the way that you build a home is based on the floor footprint and the wall locations, and you go up from there, and then you fill in studs, and you're always referencing pre-existing construction. You're referencing existing envelopes of floor space and room sizes, etc. And look I'm out in space here. There is no room. I'm just making a set of stairs. Normally, if I was building a set of stairs like that, I'd be working in the stairwell around walls, and it wouldn't matter whether you did plan out everything with CAD. In the end, you're going to stand there and measure the space and build it in tightly to fit the space. And so there's a bit of a difference in the workflow in set construction. But in the end, we'll have something super robust and built the way that you'd build any sort of stairway. We're going to counterweight it so it doesn't want to tip over. We're going to put it on wheels so they can pirouette and do sort of a set changing dance. And we will force all this lumber from beginning to end by making good choices on what pieces to use where and assembling it in a strategic way. So that's a little bit on that, and we may come back and look at that again. Thanks for watching. We'll see you.